All right, so exponents and their derivatives. Right, logs and exponents are inverses of one another. They undo each other, so they work together. And kind of like yesterday where we spent a few minutes doing an algebra review because we thought maybe there might be someone somewhere who didn't remember everything about natural logs. Well, same thing may be true today. It's possible that there exists someone who doesn't remember what's going on with e to the x. So for that hypothetical student, none of you of course, let's do some of that same stuff we did with natural log. So we'll do a graph. And we'll talk about some properties. So let's graph e to the x, and we'll cover some properties along the way. This is an even easier rule than yesterday's rule. All right, what's e to the 0? Pardon? Yeah. 1. Anything to 0 is 1. So if I plug in 0, I get 1. What about e to the first? E, what's e equal to? Yeah, 2.7 something. So 1 comma 2.7-ish. How about e to the negative 1? What's a negative exponent do? Yeah, the 1 over thing, the flips it thing. So 1 over e, 1 over 2.7, I don't know what that is, but 1 over 3 would be 0.3, so we're close to that. Close enough in terms of graphing it. So maybe that's enough for you to recall that y equals e to the x. Looks like that. All right, a couple of properties. Again, this is the algebra section of the notes, and then we'll do the calculus section after that. Some properties. The natural log of e to the x. The natural log of e to the x. Well, I can move the x down front. So x natural log e. Do you remember what the natural log of e is? It means e to something equals e. So that's got to be 1. So the natural log of e to the x is just x. It's very much like the square root of x squared, right? They just cancel each other out, and then you're back to x. So the natural log of e to the x is just x. Also, e to the natural log of x. Well, same thing. Those two things cancel each other out. That would be like squaring the square root. Like it doesn't matter what order you go in. They cancel each other out, and you're back to x. Algebra stuff. All right, let's solve some equations. So this is still algebra. We're still going to be doing algebra. E to the natural log of 3x equals 24. Well, e to the natural log, that cancels each other out. So this is 3x equals 24. So x equals 8. It turns out to be an easy problem. 8 e to the x minus 12 equals 7. Again, we're not even doing calculus right now. This is algebra stuff. What do you want to do first on that one? Add 12. 8 e to the x equals 19. How about next? Divide by 8. Now it gets a little bit dicey maybe. Maybe we don't remember what to do next. If we want to undo e to the x, we know that natural logging it would undo the e part. So I'm going to natural log both sides. Right, just like you can add 5 to both sides, or you can square root both sides, or you can divide both sides by 12. You can natural log both sides. And the reason you would do that is to get that x out of the exponent and down front. And then on the other side, that's a calculator ready answer. So in here, that's fine. That's an exact answer, and we don't even want to mess with that. Like, why take the time to type it in? Like that's good. That's our answer. Let's do one more algebra equation to refresh our brains on working these type problems. Then we'll worry about calculus. Natural log of x minus 2 squared equals 16. Bring the 2 down front. And we could divide by 2. Projector didn't want to work. And then we can do the loop-de-loop wraparound thing to undo the natural log. The screen up here is like just flashing back and forth. It's quite the sight. There we go. So you do the fish hook or the loopy-loop. So e to the 8 equals x minus 2. So x equals e to the 8 plus 2. Again, all of that is algebra. Algebra, 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 algebra. So I'm going to just call this subset of the homework optional. This is algebra practice. If you followed all that and you think you're fine, then maybe you don't need to do this. EOO for every other odd. Every other odd. So that's 4 or 5 questions. That's just working with the algebra stuff with logs and exponents. So if you need it, do it. If you feel comfortable, then don't worry about it. That's not calculus. That's algebra. All right, let's switch to calculus. So, calculus time now instead of the algebra part of 5 point whatever section this is. We jump around in this section a little bit. 5.4. Right. d dx, the derivative of, take the derivative of e to the u. The book likes using u rather than pink triangles, but I prefer pink triangles. Here we go. So there's another new rule. You got to know this. no other way around it. You just have to know that the derivative of e to the u is e to the u. It's kind of weird. It's the same thing, but chain rule times du dx, or u prime. If you prefer the land of pink triangles, then the derivative of e to the pink triangle is e to the pink triangle times the derivative of the pink triangle. Right? Those say exactly the same thing. One has a more official looking U, the other has a silly looking pink triangle in it. But it's the same thing. So you just keep the e to the whatever and then multiply by the derivative of the exponent. So let's do some examples. So y equals e to that thing, so dy dx equals e to that thing. Chain rule, though, times the derivative of that thing. Make sure you put the derivative in parentheses so all of it gets multiplied, not just whatever the first term would be. So that would be negative 4x plus 3. And that's it. So you just keep the exponent thing the same, but then chain rule off of whatever the exponent is. And people might write this in a little bit different order because we'd like that in front. And again, it's got to be in parentheses, because if the parentheses aren't there, then you're only multiplying the 3 to the e to the exponent. So all of it's got to be multiplied. So the parentheses feels like a minor deal, but your problem's not right if they're not there. Y equals x squared e to the negative x. What rule are we going to need here? The product rule. F, G, F prime, G prime. Why don't you see if you can take it from there? So find F prime, find G prime, and then put it together with the product rule. So first times derivative of the second. So x squared e to the negative x times negative 1. That looks a little bit weird, but we'll fix it later. The negative 1 at the end like that. Plus second times derivative of the first, 2x e to the negative x. That's a perfectly good safe stop, but you know that CalcChat and multiple choice, back of the book, they're going to get creative, and they'd probably take out an x and an e to the negative x. And that would leave negative x plus 2. So there's your multiple choice answer. And I think, like usual, you can get from free response to multiple choice without that much difficulty. So when you're checking in the back of the book, just know that you're fine to leave it like that, but can you recognize that what the back of the book has is the same thing as what you have? And sometimes that's the trick. Y equals 2e to the 3x over x squared plus 1. So what rule is that going to require? Quotient rule. So why don't you try that one? So there's the pieces. f prime and g prime. So I'm going to pause it again, and you can see if you can put it all together. All right, let's see if we can piece this thing together. So dy dx equals gf prime. So x squared plus 1 times 6e to the 3x, gf prime, minus fg prime. 2 times 2 is 4, x e to the 3x, all over x squared plus 1 squared. Perfectly good free response answer, but both of those terms have something we could factor out. So we've got to get used to using our algebra still. They both have an e to the 3x, and we could take a 2 out of there. So let's factor out a 2 e to the 3x and see what that leaves us with. So in the first one, we took the e to the 3x, we took 2, so that would leave 3 x squared plus 1. And on the second one, we took out, well, the minus sign still there, took out e to the 3x, divide the 4 by 2, and there's still an x there. So something like that over x squared plus 1 squared. And my guess is CalChat would probably distribute the 3, but that's close enough. You'd make it from there. All right, let's do 2 more examples. Yeah, we're okay on time. And I guess, like always, the new rule isn't really that big a deal. It's just putting it together with all the other rules. Something like this. Put it where you can see it. There we go. That looks terrible. Y equals natural log of 1 plus e to the x over 1 minus e to the x. Let's do some algebra first. Otherwise, we've got quotient rule staring at us in a minute. I don't want to do that. So let's split this up using algebra. This is kind of yesterday's assignment, or yesterday's stuff. Now this is going to be a little bit easier. Not a ton easier. Well, no, I'd still say a lot easier. Not an easy problem, but a lot easier than it was going to be. So y prime, or dy dx, derivative of natural log is 1 over the argument times the derivative of the argument. So what's the derivative of 1 plus e to the x? E to the x times 1, if you want to put that on there. And then minus, that minus sign, 1 over the argument times the derivative of the argument, which would just be negative e to the x. So the negative will make a positive. I'm going to rewrite this a little bit cleaner. And that's our safe stop right there. We're good. Except that this is one where the book or CalChat is going to do some algebra and you're not going to be able to recognize the final answer. Like a lot of times you look in the back of the book and it's, like one small algebra step away and you're like, oh yeah, I'm fine, I'm good. This one, when you see the final answer, you're not going to recognize it because what they're going to do is get a common denominator. So the first one goes 1 minus e to the x top and bottom. The second one gets 1 plus e to the x top and bottom. So we got our common denominator now. And we got a mess up top. E to the x minus, what's e to the x times e to the x? Remember how to do that? Oh, perfect. My face is over the answer.
2x.
E to the 2x. So minus e to the 2x. And then the second one, plus e to the x plus e to the 2x. And so those e to the 2x's will cancel out. And you got 2 e to the x over 1 plus e to the x, 1 minus e to the x. There's your multiple choice answer. All right. It's a great example of calculus is easy, algebra is hard. I don't know why I'm writing that down. You don't need to write that down, but sometimes it feels that way in here, right? Like grading your test, you get the calculus step right, and then the algebra blows up on you, and you mess up exponent rules or whatever. Last example. Find the equation of a tangent line. What does that mean? What do we need to find in order to find a tangent line? What's that? A derivative. But just in general, even before we talk calculus, what do I need to find an equation of a line? What two things will I need?
A point and a slope.
A point and a slope. So I haven't even finished this problem, and my brain is already thinking, okay, I'm probably going to need a point and a slope. So find an equation of a tangent line to x e to the y plus y e to the x equals 1 at 0, 1. So that's a weird looking thing. But big picture, the point they gave us, that's 0, 1. The slope, that'll be dy dx at 0, 1. So I kind of know where I'm headed at least. Finding this derivative is going to be yuck, but at least I know why I'm doing it, where I'm headed, what I'll do with it when I get it, right? Y minus y1 equals whatever the slope is times x minus x1. That's where I'm headed. But I need to find the derivative of this thing. Ooh. Product rule. So 2 product rules. Maybe we should write this one out. We'll write this one out, but not the next one maybe. So what's the derivative of f? 1. What's the derivative of g? Good, e to the y times dy dx. Because anytime there's a y in there, dy dx has to show up. A few of you forgot that a couple times on the test, doing implicit differentiation. Anytime you're taking derivative with a y involved, dy dx is going to have to show up. Alright, so back up, product rule, first times derivative of the second, so x e to the y dy dx, plus the other way around, second times derivative of the first, that's pretty easy, e to the y. So all of that came from that guy. And then we need to do product rule again on this guy. Although I think for this one I'll do one in place, because I want some of you to get to the point where you don't have to write everything out. You can just think in your brain, first times derivative of the second, plus second times derivative of the first. So first times derivative of the second. What's the derivative of e to the x? E to the x. Times 1 if you're thinking chain rule. Plus, vice versa, the second times the derivative of the first. What's the derivative of y? dy dx. And then sure enough, at least one person in this class made this mistake on the test. So frustrating to get all the hard stuff right. And then what's the derivative of 1? 0. I mean, I know that person knows that. They just copied down the 1 instead of thinking about a derivative. All right, so this guy and this guy will go to the other side. So minus e to the y minus y e to the x. And by the way, since I'm going to be plugging in 0, 1, I don't really care about factoring out or making things look good. I mean, I'm going to plug in 0, 1 and take care of that later. Factor out dy dx from what's left. By the way, the calculus is done with this problem, right? We did the hard stuff. Now it's the, quote, easy stuff, the algebra. So factor out dy dx from what's left. So x e to the y plus e to the x. So then we'll divide it over. What a mess of a problem. Fortunately, we're plugging in zeros and ones, so hopefully we get something that's reasonable to deal with here. Let's see, so negative e to the 1 minus 1 e to the 0. I don't know that qualifies as reasonable or not. I guess e to the 0 is nice. Then in the bottom, again, I'll clean that up in a minute. I'm just plugging things in right now. X is 0, e to the 1. Of course, that's going to go away. Plus e to the 0. So negative e minus 1 over 1. So that's not as awful as it could have been. Still yuck, but not as bad as it could have been. What did we just find before we get lost in the process here? What is that? The slope of what? Yeah, the slope of the tangent line we're trying to find. So y minus 1 equals that slope, negative e minus 1, times x minus 0. And you don't need the x minus 0, but it's okay to leave it that way. Again, when you're writing a tangent line, you don't just put the derivative right there. You got to solve, you got to figure out what the derivative is and put it in there. Some of you like to just find f prime and stick it there. But you got to find the f prime at that particular point and put it in there. So that's an ugly example, but that's a reasonable example for what we could ask you to do. All right, page 352, 25 to 28 all, 33 to 49 odd, and then 55, 57, 63. And I've got a note in my notes here. Let me see what's going on with 67 or 65. Oh, we just did 65. That was example 5. So you don't really need to do that one because we did it already. All right, so the question keeps coming up is, are we going to have homework over the break? And my answer is, that's up to you. That's the last assignment I'm going to give you before the break. So if you do it tonight, then no, you don't have homework over the break. If you decide, I'll wait till, 10 days from now on Sunday night and do it, no, you won't. But if that's your thought process, then yeah, you're going to have assignment over the break. So we will do some stuff tomorrow, so if you're tuning in on video, I'll post a video of warm-ups and that kind of stuff tomorrow. But there won't be an assignment. So knock that out tonight, and then you'll have a clean break, at least in terms of calculus.